Okay guys, welcome back. It's been very long time since I uploaded any video. Actually I was busy in many projects and I was not getting time, but finally I have managed to squeeze out some time for this video. So basically I was planning to make different videos about different projects that I have made. First off, uh, which is an ES or brushed ESC, which is like production grade all ready and it's working flawlessly. And like I just wanted to help out the community because there are, although there are ESCs available in the market, like many good ESC, but those are quite expensive. These are all Chinese clones. I'm not talking about this C20M's first ESC. These are all brushless. I just need like let the technomotives one. Yeah, you see, yes. These are already available in market, but they are expensive. 3250, 2500. It's not cheap. Uh, but if you can make it yourself, you will save quite a lot of money. So I was also planning to like sell it, but again I thought, why not help the community? So I'm making this video to share exactly how it works and what goes into making a brushed ESC in detail. Right. I don't know if you can see, but I have made a whole list of what topics I will cover, and it can't be done in one video. There will be 4 to 5 videos in this series. So make sure you follow the channel and subscribe to the channel so you can see the video. And so coming to the first part is understanding the basics, right? What is an ESC? So basically, ESC stands for electronic speed control, right? It basically controls the speed of motor. ESC can be different types: brushed ESC, brushless ESC. But in this video, basically in this series, I will be talking about brushed ESC specifically. Brushless also I will cover later on, but for now, let's focus on brushed ESC. So, electronic speed controller is basically a whole unit which comprises of a power electronic section and a logic section. So you give input to the ESC and it converts the input into electrical signals and processes the information, and then it outputs the voltage according to your given signal. So it can drive the motor. These are the very basics, right? So after that, let's do a quick analysis of an ESC. So this was the ESC from Mobitronics. A huge thanks to them for sharing these images on Instagram. Uh, it helps us a lot. We can see how the connections are made, what components are there. So you see, as I have told, the ESC comprises of two sections. The, this is the first thing. This is the power section, power electronics. So these are the MOSFETs. This part handles the high voltage, high power, and here in the same 20D, these are the MOSFETs. This part handles the high power, and this part is the logic part. So this part operates on low power, right? So you can see this part. This is what translates your signal into electronic signal through which the MOSFETs can provide the output. And after that, we will go into the component selection. Alright. So component selection also includes the datasheet study. Datasheet study is a very crucial part in designing any electronic circuit. You know, because you have to know what component you are dealing with, right? And to know the component, you will have to like you will have to know its datasheet. Like you should be able to study the datasheet. So now we know that there are MOSFETs, there are logic level powers. You see, this is the microcontroller. These are the gate driver IC. These are the LDOs, or voltage regulators to provide the necessary voltages, the microcontroller and the battery elementary circuit and all. First of all, let's see MOSFET. Okay, so about each of the things I will explain in detail the working principles like MOSFET, what is MOSFET, MOSFET versus BJT, NMOS, PMOS, all of the working next video. But for now, let's see MOSFET. So MOSFET is basically a semiconductor device consisting gate, drain, and source. And actually, there are two types of MOSFET: MOSFET N channel and MOSFET P channel. Right. So we always use N channel in case of ESC because N channel has very low resistance from drain to source. Okay, this is the main purpose of using N channel MOSFET, and I will also explain why we don't use P channel and what could be the advantage of using P channel later on. But for now, let's understand we use as a general rule we always use N channel MOSFET for an ESC because it has low resistance from drain to source where the main power flows. Okay, so we use MOSFET N channel and it is of enhancement type. Okay, so enhancement type is basically it is normally off, and when we apply voltage to gate, then it starts conducting. Whereas in depletion type, it is always on, and we have to uh, give voltage to gate to close it. So we always use enhancement type MOSFET. Generally, I think most of the MOSFET are enhancement type only, and after that, we will see just. So after MOSFET, uh, since we have covered the power section, this is the MOSFETs. Now we will need to use some microcontroller, right? So I will be using Atmega 328P. So Atmega 328P is the same microcontroller used in Arduino Uno and Arduino Nano. These are 8-bit microcontroller and are very good in case of making an ESC, like very easy to program and write code, and there are many GPIO pins. So I will explain everything in detail in the upcoming videos, but for now we will be using the Atmega 328P microcontroller, and after that uh, this is the MOSFET, this is the microcontroller, and then these are the complementary components, right? The crystal, the filtering caps, uh, these are the gate drivers. Okay, so now let's talk about gate driver. Let's see. So basically, why is gate driver used? So what is, first of all, what is gate driver? So gate driver is basically an electronic component that is used to provide uh, the required voltage to the gate of the MOSFET to turn it on. Because not all MOSFETs can uh, directly run with the pin of microcontroller, right? So for example, let's say let's say we take IRF 3205. This is a very common MOSFET And let's first study the datasheet. Okay, so to study the datasheet first, we need to look at the ratings. This is the symbol, gate, drain, and source. This is the drain to source voltage max, 55 volts. So as a general rule of thumb, whatever is the drain to source voltage, we always use 20 to 25 volts less than that, because a voltage spike can destroy the MOSFET if we go near the limit. So if it is 55 volt, we will use around 30 volts max or 25 volts. That will be a very good and safe margin. And this is the RDS on drain to source resistance, which is 8 milliohms. I will explain about this in detail. RDS on, this is ID, means drain current, which is 110 amps. So let's see now here, drain current at junction temperature at the TC, means the junction temperature, the PN junction of the MOSFET. If it is 25 degrees Celsius, then we have continuous drain current at voltage gate to source at 10 volts. Now you see, focus on this slide. VGS at 10 volts. What does this mean? This means that if we apply a voltage at gate, uh, so the from gate to source the voltage is 10 volts, then uh, it will conduct around 110 amps if the junction temperature is 25 degrees Celsius. So now you see, I have told why use gate driver, because uh, voltage we will have to apply at gate, right? So the microcontroller that we will use at Mega 32HP, that operates on 5 volts, and they have like 10 to 20 milliamps capacity of their GPI, like current capacity. So uh, these MOSFETs require 10 volts, minimum 10 volts, and they pull a good amount of current to like turn on the MOSFET. So if we directly connect the gate to the microcontroller, the MOSFET will not turn on properly, and the microcontroller will also be destroyed. So to interface microcontroller and the MOSFET, gate driver is used. Okay, because gate driver helps in taking small logic level signals and converting into power signals, so the MOSFET can turn on and operate properly. And now you see, let's ignore this component. I have not used this, and these are the voltage regulator. So voltage regulator are of mainly two types. One is linear and one is switching type. So linear are basically the LM7805. These are all the linear regulator, uh, which that gives out the excess voltage as heat. So, and the switching one is like buck, boost, boost, all those things. These are the switching types. So, as a general rule of thumb, if your load is less than 100 milliamps, use linear, no issues. But if it is greater than like 300 milliamps, uh, always use switching, because switching regulators produce a lot less heat, and you may require some extra filtering components, but they perform a lot good in case of heavy loads. And you see, these are all the filtering caps, and these are all ceramic caps. These are tantalum capacitors, and I will tell you why we use ceramic, tantalum, and the electrolytic, and where do we use all those things. Like if we use uh, electrolytic in place of ceramic, it won't work properly. I'll tell you that. And after this, okay, so I think the main components I have explained what to use, and in the next video I will discuss on the working principles of the MOSFET, uh, like what is MOSFET, the MOSFET versus BJT, like NMOS, PMOS. I think NMOS and PMOS I have explained. Those are the basic thing, and we don't need it anymore. And the main things in MOSFET I will explain. What is Miller plateau? What is linear region? What is the switching frequency? What is RDS on? What is gate threshold voltage? What is gate charge and total gate charge? And next I will cover what is gate driver, why do we use bootstrap capacitor in case of internal MOSFETs, and what is high side versus low side switching, what is dead time fixed versus programmable, what is source and sink current, dual versus single input gate driver, input versus output of gate driver, and about the microcontroller also, what do we use, how do we select, what are the specs, what are the feasibility of a microcontroller, and finally the system design. So the system design will be basically about the PWM signal, uh, what are the types of signal. We will basically use PWM signal, but I will explain what are the different types of signals, about the fail safe that is used in ESC, and about the bidirectional control range mapping, because uh, in brushed ESC, when we used to drive any robots, we need bidirectional control, right? Forward and backward movement. So I will explain that also. How do we interface the signal to run the motor in two directions? And after that, there will be two more videos. And after that, the first video will be about schematic design and layout and routing. And after that, finally, we will program our ESC, write the firmware, and then make it production ready. So this was all for this video. And, we'll meet in the next video. So till then, you can subscribe to my channel and click the notification bell, so whenever I post the next part, you can watch it as soon as possible. Okay.